Describe what you mean by the bladder of this structure.
Okay, the bladder is this inside layer. It's coated in polyethylene, which is like a rubber, and that's to keep the air from going out. The idea is we don't want this even leaking a little bit. Anything in space is going to leak a very small amount.
Right.
So we want them to keep their air as long as possible. So we've got that on the inside, and it usually doesn't maintain the structure, the tension that's caused by the air. It's just here to protect the air from going out.
Okay.
So it's a little bit larger, so there we get little wrinkles sometimes if it's not totally inflated
it's
like it
stretchable.
is right now. It's very stretchable.
Very stretchable.
So that's what the inside is made out of.
All right, Judith, I think we're equalized. We ready to
Okay,
go?
Sure thing.
That is so cool.
I'm so glad you enjoyed it.
Oh.
Very happy to show it to you.
So we know NASA is not just going to send up these inflatable structures to the moon or Mars without testing them first, but where on Earth do you test these structures to make sure they can withstand the rigors of space? NASA packed an inflatable structure habitat and sent it down to McMurdo Station, Antarctica, where the focus was to see how easy it was to deploy and how it held up under those harsh conditions. A small group unpacked and set up the inflatable, then began to inflate it. Once the inflatable was laid out and secured, about 6 minutes later, it was fully inflated and ready to be used. This is good news because although the conditions are tough down in Antarctica, it will probably be just a little bit harder on the moon, where astronauts have to carry their own oxygen and work inside bulky spacesuits. You may wonder if this inflatable structure can actually hold up on the moon and Mars. Why doesn't NASA just send up rigid structures? Well, there are a lot of reasons, but two of the most important are storage and weight. Right now, this huge inflatable structure can fold up into a very small space for shipment to the moon, and it's considerably lighter than rigid structures. Now, this is important. To land 1 pound of supplies on the lunar surface, NASA must launch 125 pounds of hardware and fuel to get it there. Another benefit is that this inflatable structure can be taken down and redeployed multiple times, permitting exploration beyond the initial landing area. So it looks like NASA is on the right track.
Okay, so earlier in the program, we showed you how NASA is working with the IndyCar series to help make changes in safety and technology. But they're not the only racing series that NASA is working with. That's right, NASA's also helping NASCAR to help make improvements in their cars too. Of course, many of the NASA technologies found in IndyCar and in NASCAR are the same. But there are some unique characteristics found in stock car, not found in IndyCar. So what are they? I cruised down to Mooresville, North Carolina to speak with one of the premier teams in all of racing, Team Penske. Can you tell me some things that NASA has been influential with auto racing?
Yeah. In fact, we've got some good applications that we use right here. A lot of them are related to how we protect the driver, keep his head in the game, so to speak. Obviously, one of the byproducts of combustion is carbon monoxide. Bad stuff.
Now, many drivers have complained about headaches, nausea, and dizziness. So, to help these drivers with this type of sickness, Team Penske once again worked with NASA. The solution came from a NASA project called the Low Temperature Oxidation Catalyst that was originally designed for use on space-based atmospheric lasers. So Penske engineers took the basic idea from NASA and then designed a catalytic air filter that removes over 99% of all airborne particles. Once the particles are removed, the air is cooled and pumped into the driver's helmet, giving them fresh, clean air. With this new development, carbon monoxide sickness in drivers may soon be a thing of the past. And this may seem pretty obvious, but one key difference between IndyCar and NASCAR is that NASCAR vehicles have a roof. So why is this so important? Well, one big factor is heat. In an IndyCar, the driver is exposed to a 200-mile-per-hour wind stream, which keeps them relatively cool. But in a stock car, the roof keeps a lot of the heat inside, allowing temperatures to reach upwards of 160 degrees. To combat this, NASCAR teams began insulating car cockpits with the same type of thermal protection system that protects the space shuttle when it re-enters the Earth's atmosphere. This addition only added 4 pounds to the car, but cut the heat inside by over 50 degrees.
We're always questioning the design. First thing is, we have what's called a scale model program. We have a car just like this, but it's 45% of that in every detail. We'll blow that and do design studies on that to figure out, how things work.
Right?
Second thing is we'll take these full cars and we'll blow them in a wind tunnel.
Sure.
We've done it at Langley.
NASA wind tunnel.
Yeah, you
you
go.
are at Langley.
Another way is purely theoretical, to use computational fluid dynamics to look at the flow of the car, which is all mathematical. If you take all of those approaches and combine them, you start to get a full understanding of what's going on and how to make it faster.
Doctor, what inspired you to become an engineer?
Well, NASA had a huge role in it. I grew up in that community, watched all the moon launches from my front yard. So it was just a part of that culture. And science and technology and engineering as applied science, it was a natural for me. So I couldn't say no. Haven't regretted it since.
So Kent, thanks so much for having us down here at Penske Racing.
No problem.
Definitely, and we'll be seeing you at the next race.
Enjoyed it.
Take care. So we have learned a lot today about exploration and how NASA technologies are helping out in auto racing. And with us going back to the moon and on to Mars, there's no doubt that tons of these NASA technologies will be converted to be used in our everyday lives. Yeah. Jennifer Pulley, I'm Johnny Alonso. Catch you next time on NASA 360. Help us find out about the cutting technology to cutting edge.
What about the most
And how NASA technologies are helping out. Again?
Dozens of national. Yeah. Right. Okay. So what is that?
So Kent, thanks for having me down here at Penske Racing.
No problem.
And
Enjoyed it.
we'll be rooting for you too. Do it again. So Kent, thanks so much for having us down here at Penske Racing.
No problem. Come back anytime. Enjoyed it.
Definitely, and we'll be voting for you. Jeez, I can't get this done. You're moving the car, I'm moving it. I'm voting, rooting.
or actually can be found? Ah!
So to find out what some more of these NASA-inspired technologies are, I came here.
Oh, that was it. Driving in a family car, zipping around in an Indy car. Sure bet that, whatever, the last line.